Well, there's more than one way to do this problem, but here is the general technique. Here's the answer. There's the parabola. There's the function in the form ax squared plus bx plus c. And there's proof that that parabola goes through those 3 points. The question is, how did I come up with that equation? Well, if we start with standard form, y equals ax squared plus bx plus c, the fact that the parabola goes through these 3 points allows us to draw these conclusions right here. So we can end up with 3 equations and 3 unknowns. When x equals 1, we'll get a plus b plus c equals 6. Because when x equals 1, y equals 6. When x equals 2, we'll get 4a, 2 squared is 4, plus 2b plus c equals 5. And finally, when x is 0, we just get c equals 5. So that allows us to immediately go to a plus b plus 5, because c is 5, equals 6, or a plus b equals 1. And when c is 5, I've got 4a plus 2b plus 5 equals 5. Subtract 5 from both sides, I get 0. So here we have 2 equations, a plus b equals 1 and 4a plus 2b equals 0, solved by either substitution or addition elimination method to get the values for a and b, which is what I did. A is -1, b is 2, c is 5. Okay. We might also notice that these 2 points here, the 0, 5 and the 2, 5, are along the same horizontal line, so the axis of symmetry has to split those two. So that's another way to solve this particular problem. Most of the time when you see problems like this, you have 3 equations, 3 unknowns, and you have to learn to solve a system of 3 equations and 3 unknowns. It's a little more complicated than this one. Okay, there you go.